Woman, birth, death, infinity.
Good afternoon, and welcome to the Your Health television program here on AMP's Cable Channel 24 and on the internet at www.ampmedia.org. Join our rotating host and their informative guest live every Monday afternoon at 4 o'clock. The purpose of the Your Health television program is to help get, make, and keep listeners and viewers like you healthy. And now, ladies and gentlemen, on with the program.
Welcome to the Your Health television program hosted by the Monterey County Health Department. I'm Emily Sciolto, your host today, and just about every third Monday of each month. People use water every day for drinking, recreation, agriculture, and industry. According to the Centers for Disease Control and Prevention, the United States alone used 408 billion gallons of water daily in the year 2000. That's the equivalent of almost 1,400 gallons of water for every man, woman, and child, or enough to fill 14 standard-sized bathtubs daily. This amount includes both direct use, such as drinking, bathing, and flushing the toilet, as well as indirect use, such as watering the lawn, washing the car, and commercial and industrial use. Drinking water comes from a variety of sources, including public water systems, private wells, and bottled water. Here in the United States, the drinking water is among the safest in the world. However, our water is still susceptible to contaminants that can cause health problems such as gastrointestinal illness, reproductive problems, and neurological disorders. There are many sources of water contamination as well, including naturally occurring chemicals and minerals like arsenic, nitrates, and cadmium. Other sources of contamination include local land use practices like fertilizers and pesticides, manufacturing processes, sewer overflow, and malfunctioning septic tanks, for example. Ensuring safe and healthy drinking water may be as simple as turning on the tap from a regulated public water system, while other water sources may need a water filter, a check on water fluoridation, or an inspection to ensure a septic tank is not too close to a private well. It's important to know where your drinking water comes from, how it's been treated, and if it's even safe to drink. So here today to help us do just that are three guest experts from the Monterey County Environmental Health Bureau Drinking Water Protection Services Division. Sitting across from me now are two of those three, Ms. Cheryl Sandoval, Supervising Environmental Health Specialist, and Ms. Marni Flagg, Senior Environmental Health Specialist. Welcome, ladies, and thank you for being here.
Thank you.
So let's begin with some basics. Tell us what you do in the drinking water program.
Well, in the drinking water program, we really have two main programs. The first is well construction, and then the second is looking at drinking water systems, domestic drinking water systems.
So what's your main objective in the well program, let's say?
In the well program, our main objective is to keep the water safe in Monterey County, and really we want to make sure that the well is constructed in a way that it is not going to cause groundwater contamination. We also want to make sure that the water coming out of that well is safe for what its intended use is. For well construction, there are several different things that we look at in the process, and some of the things that we look at include making sure that it is located in a place such as not too close to the septic system, located from hazardous waste facilities, and just that it's going to be in a safe place, that you don't get contamination from that. We also want to make sure that it's drilled properly and that it doesn't become a conduit of contamination. It's really complex geology in Monterey County, and we want to make sure that we keep our aquifer safe. If there's one contaminated aquifer, the well doesn't allow it to go into the lower one.
Okay, so there's a handful of things you just mentioned there.
Yes.
For wells. So what about water systems in general?
For water systems, we regulate the initial permitting of the water system and also ongoing. And we regulate systems from 2 to 199 connections. Once you get over 199 connections, the State Department of Public Health takes over the regulation. For new systems, we want to make sure that they're set up in a way that they can be successful. So we look and we want to make sure that they have a good source of water that meets quantity, so there's enough water that it meets quality so the water is not contaminated. We also want to make sure if a well is shared by people that there's a water system agreement, and so it's clear who's responsible for what. We look at, they have a budget to make sure that they're collecting enough fees to have ongoing oversight of the system. For systems, we regulate an annual permit for drinking water systems too, and for that we do inspections to make sure the infrastructure is kept intact. And we also look at water quality monitoring. We make sure any notification for problems is distributed. We provide a lot of technical assistance and education to people, and we also deal with complaints.
So that's a ton of stuff. About how many small water systems are there like this? The anywhere from 2 lines to, what did you say?
Well, there's a breakdown between the 2 and 199. We have our 2 to 14 connection system.
Okay.
Would have a little bit less requirements for those, and we have about 980 in this county. And then for the public water systems that are 15 or more, and also some of the business parks, schools that may not be residential, but they serve the public. And we have about 286 last count on the public system.
So you guys have a lot going on. There's like quite a few systems that you're monitoring, maintaining, providing that technical assistance to.
Yes.
Okay, so you're not bored at work, or your to-do list is full. So what if I have my own well? Would you come out for regular inspections?
No, for private wells that it's only one house, one well, we regulate the initial construction of that well. And if there's a house being built, we want to make sure that there's enough water and that the water is acceptable quality for the house. But after that, the homeowner is on their own. So it is important that they know how to take care of their own wells, since we won't be regularly out there looking at things.
Okay, so I've got to be prepared. I can't just say, I need some water, I think there's well, or I think there's some down here, let's drill it, let's figure it out. You guys are really going to make sure that I have all my ducks in a line. My permit, I'm friends with the people who I'm sharing the well with, and we have kind of everything set up to be successful.
Right.
Wonderful. So Marni, tell us what you guys do in the field.
Like Cheryl said, we visually inspect, initiate compliance, and provide education about wells and water systems.
Okay, so if I have a well, then what do I need to do to take care of it?
Wells are constructed to be fairly self-sufficient. They do need maintenance, though, like a car. They'll last longer and be more efficient if you give them a little TLC. First, you want to know where your well is. If you share your well, it might be on your neighbor's property, so that's definitely something to look into. And secondly, once you find your well, you want to develop a system to visit it monthly. I'll show you the ins and outs of a well. Taking a look at this poster board, we'll start with Well 101.
Oh, okay. Awesome.
Starting at the bottom.
What is that? I guess the bottom right?
Yeah, start the bottom right of the poster board. We begin with underground, and you can see that right about here is where the surface is going to be, and so down here is going to be considered underground. Your well can be drilled anywhere from 100 feet to 1,000 feet deep, depending on your location within the county. Usually your hole is drilled a little bit wider than you need it to be, and once you insert your casing, which can be made of PVC or steel, it's usually a little bit smaller than the original drill hole size. You want to make sure that you have your screens or perforations in the well right about here, where the water is in your formations around your area. That's really important that you know where the water is, and we have information that we can use to help facilitate that. You also want to make sure you seal your well. From the ground to a certain point, they have to be a minimum of 50 feet, but they can go up to 400 feet or more. And the purpose of this is to seal out layers of formation that might have contaminants, and to also make sure that your well isn't a direct pipe down to your aquifer. We fill, from the seal down is filled with gravel, and that just helps water percolate from the aquifer into your well so you can draw it up and use it. After that, we insert a pump, and this is called a submersible pump, which is down underneath, and that's opposed to a turbine pump, which you might see out in an ag field. Those are very large, and they're usually kept on top of the well, up at the top. But the submersible is responsible for drawing the water up and putting it out the pipe. So after that, you get to the surface, and above the surface, you usually have your casing above the ground a few inches. And this is an ideal well. This isn't the type of well that you'll see every day. You definitely want to make sure you have a watertight seal, and that's accomplished by bolts in the top, sealing a plate on top of the well. There's usually a port for disinfection, and that is usually on the top in the middle. There's a couple of places that you can insert things, and so you have your port for disinfection. You have a well vent that comes out the top. It's usually 18 inches off the ground, downturned and screened, and this is how the well breathes. A well is a very dynamic kind of organism in a way, if you will. Once you remove the water out with the pump removes the water and puts it up, and the well needs to replace the removed water with something, and it's going to be air. So the vent is responsible as the conduit for the well to breathe back in the air, and you want to make sure that it's downturned and screened, and the reason is so it doesn't suck up anything that's not fresh air. The closer your vent is to the ground, the more likely it is that you'll suck up something else. Lots of times there's a sample tap on the well, and that's just so we can remove a little bit of water and test it. That's also downturned. There's no screen usually on sample taps because there's a valve to turn it on and off. Also at the top of the well, there is a port for the power cords that go down to the pump, and we usually make sure that that's a watertight conduit. If you think about it, that would be another place that air could be sucked in to the system if you don't have a vent. And finally, we have the well slab at the top, and we usually like it to be 2 feet on either side and 4 inches thick, and it slopes down so that if there's rainwater on it, it slopes off and doesn't go straight down into your well at all. So now that I've explained the parts usually in the visual aid, I'll explain a little bit how to maintain it.
Wonderful. That was a very technical explanation. No, thank you. I mean, for those of you out there that have a well, this is you want to be paying attention to this one.
You want to make sure that you keep the well area clean of debris. Make sure there's no animals around your well. Keep all those bolts really tight, loose bolts. Anything can get in there, water, sprinkler, anything you want to spray out there will go right in. Keep your screens on. Okay. And a screen would be about the size of a window screen.
Oh, that large. Well,
the mesh.
Okay, the mesh is
a little. It's really small. It's tiny, and they do it that way just to make sure that nothing gets sucked up. But if you ever have to replace it or you want to do something about that, a window screen.
Okay.
Is sufficient.
Oh,
type of screen.
You can even cut that out.
Yes.
Aha, I get where you're.
Yeah, do it yourself.
DIY well
do
screen.
It yourself.
Okay.
Yeah, Wells 101.
Yeah. So quick question though. So nothing is going to get in here. Nothing gets in the well.
Theoretically.
Okay, and you would know if you turn your sink on and there's stuff in your water. That's how you're going to tell.
Most likely, if that happens, there's a hole in your distribution system somewhere.
Okay.
If you actually have articles coming out of your tap.
Okay.
Very rarely would something like that actually be sucked up by the pump.
Okay.
And put out in the distribution system.
I guess I was just trying to figure out how you can tell if there's an issue here.
We will, usually you test your water.
Okay, and we'll get there.
Yeah, we'll get there, and we'll talk about that.
Jumping the gun on you, sorry.
That's okay. Besides the screens, you want to make sure that you protect the casing, which, PVC is plastic, so over time that can corrode, and you just want to make sure that you're watching out for these things when you go out there every month. The slope of the well slab is also really important to protect that casing.
Okay.
So it'll keep nothing will pool around it, and nothing could happen to it at all that way. Another way to protect the casing is to maybe construct a housing over your well.
I was going to say, like a little protective shed or something.
Exactly.
Okay.
But when you make a house for your well, you're potentially making a house for someone else.
Yeah, animals.
Yeah,
Okay.
so you do want to make sure that it's tight and that nothing is living in there, no little critters, because that's definitely going to affect a lot of things. Sometimes just a roof over the well. If it's out in the open, in fields, we have a lot of wind here.
Yeah.
And a lot of areas that a well could just definitely get worn down. So even a roof would be better than nothing.
Just a little overhang.
You want to watch for cracks. And if your well is made of steel and you're near the ocean, you want to watch for rust.
Okay.
So a lot of wells can be worn down by the sea air and the salt.
Right.
So,
and I was going to ask, what's the average lifespan of a well these days?
wells can last a long time. I've seen wells that were constructed, in 1920,
Yeah.
and they're still functioning. But I think it's all about maintenance and construction standards, and we work really hard to make sure that for the future we're making these wells last a long time, because we don't want to keep drilling wells.
Yeah.
I mean, you don't want to keep putting holes straight down.
Yeah. So how does a well supply enough water all day long?
Well, every system is designed a little differently. The simplest would be a pressure tank, and the distribution lines. So once you turn on the tap and use that water up, you're signaling your well to turn on.
So there's no shortage. It's not going to stop during the day.
Well, that's a lot of electricity, so what we like to recommend is that you put on a storage tank.
Oh.
And there's lots of different sizes and levels of sophistication of storage tanks. And basically you just want a reliable delivery and enough water for your peak times. Storage is also important for fire. You want to have a little water on hand if you have a fire, and also a power failure. So if you have no power for your well, then you'll not have any water.
So there's definitely a lot to think about if you have a well. Like considerably more to think about than just turning the tap on and off. And it seems like those, in some ways it's good, some ways it can be cumbersome, but if there's a disaster situation and if you have a storage tank, you're good to go for the most part, it sounds like.
Yes.
I think we have time for about one more question. Can you tell me about some of the common problems that you see?
A lot of times you have cracks in the slab, holes in the casing, debris around. We want to make sure that that's cleared.
Okay.
Storage tanks, holes in your storage tank, rust, keep them painted, keep them nice and neat. Make sure if there's any leaks, you plug them. Any openings, you have screens on them. And there's also booster pumps on some systems, and you want to make sure, again, that they don't leak and there's no rust. And they're minimal amount of storage in a pressure tank, but you don't want to use that for your only storage. And we just want to make sure everyone feels free to call us if they ever have any questions in any way. We have a lot of guidance documents available.
Wonderful.
And any questions we're here to answer.
Well, thank you, ladies, so much. You went over a lot, and some of it was technical, a lot of it was with the well, but I think you went over some really important information, and viewers certainly appreciate that. And just like you heard, if you have any questions, if you'd like any more information on anything you just heard, please feel free to visit the Monterey County Environmental Health Bureau Drinking Water Protection Services Division on the web at www.mtyhd.org/EH. That's www.mtyhd.org/EH. And right now we're going to take a short break, but don't touch that dial. We'll be back with more Your Health Television program in just a moment.